Hello, I'm Bianca.
And I'm Paloma, and you are listening to The Climate Press.
A podcast where we aim to bring together climate science with public understanding and action. In this episode, we will continue talking with Dr. Amanda Maycock and Professor Martin Chipperfield from the School of Earth and Environment at the University of Leeds. Following on with our previous episode, we will continue to talk about how the scientific community are monitoring the recovery and evolution of the Antarctic ozone hole, as well as the future projections on the ozone hole and new sources of ozone depleting substances. And if you haven't heard our latest episode, stop! Go back and listen to the first one. Thank you.
The 2018 scientific assessment of ozone depletion contains the most up-to-date understanding of ozone depletion, reflecting the thinking of hundreds of international scientific experts, among which are our guests today, Amanda and Martin. Can you tell us what are the main outcomes of the report and how do you communicate them to policymakers?
So the most recent 2018 scientific assessment of ozone depletion is just one of a series of similar reports that have been produced over the last few decades. And so when the Montreal Protocol was signed and came into effect, essentially the countries of the world asked the scientific community to update them regularly on the state of the ozone layer, so to inform them how ozone was changing, whether the depletion was still occurring, whether it was becoming worse, or whether it might eventually be becoming better and that we could start to see some healing of the ozone layer. They wanted to know about how the concentrations of the CFC compounds and other gases were changing in the atmosphere over time, and they wanted to know about other impacts of the ozone hole on the climate system. And so those assessment reports are now produced every 4 years by the scientific community, and they're presented to the parties of the Montreal Protocol when they're produced. And if there are any questions or emerging issues from those reports, then the parties of the protocol will come to the scientific assessment panel and they will ask them for some information about that. So that's the sort of scientific community providing this information to the parties of the protocol. So in this most recent ozone assessment report, there were a number of interesting findings, I think, including, for example, the first signs of healing of the Antarctic ozone layer. So there's been some new research in the last few years using observational data and some modelling results, which indicate that as a consequence of the Montreal Protocol and its amendments, and the fact that the concentrations of these ozone-depleting substances in the atmosphere have been declining since around the mid-1990s. That decline is quite slow because these gases take a long time to be broken down in the atmosphere. But as they do decline, we expect that we can start to see the ozone layer healing and recovering and the ozone hole recovering. So there were some new findings in this report that we are now seeing the first signs of the ozone layer recovering and the ozone hole is starting to heal. One emerging issue, however, is that there are clear signs now of an increase to the emissions of one of the gases, CFC11.
CFCs, or chlorofluorocarbons, are ozone-depleting substances that are used in the manufacture of aerosol sprays, for foams and packaging materials, as solvents and as refrigerants.
One of the gases, CFC11, one of the main ozone-depleting substances that's controlled under the Montreal Protocol, over the last few years. So although we expect those emissions to be declining, there's actually evidence that in fact they've been increasing, which is a big concern, of course, to the parties of the protocol, because that potentially presents a violation of the protocol. So this was probably the sort of headline message splash, if you like, from the report. Unfortunately, it wasn't a good message in that case, but the positive thing is that this has been identified, and now there are ongoing kind of series of efforts by the scientific community to identify where these emissions are coming from, what is their source, and indeed the parties of the protocol are very aware of this issue and are similarly trying to find out where these emissions are coming from and to take actions in order to stop them, basically, so that the emissions will continue to go down.
The overall message is very positive, as you said, Paloma, that I think it was Kofi Annan you quoted there when you said the Montreal Protocol is the most successful environmental international treaty to date. And I think that's still the case, because we've seen the ozone layer start to recover in response to the decreasing global abundances of these CFCs and other gases. And it's true, for the first time, this most recent assessment did detect an increase in the production of one of the controlled CFCs linked to production in Southeast Asia. And that itself is a triumph, if you like, of atmospheric measurements, because our monitoring networks have become so sensitive we can detect really, really small quantities of these gases, and the models showed that that wasn't consistent with what we expect to happen, and quite quickly, through tracing back the observations through air mass trajectories and wind patterns, it could be linked that the increases in observed abundances were linked to when air masses had been in the region of Southeast Asia. So in the past year or so, it's developed quite quickly. We now know that this increased production seems to be coming from that part of the world, and the issue's been raised, and it's up to governments, the parties to the Montreal Protocol, to sort of take action. And at this stage, we could be quite hopeful that they will investigate the causes and try and put a stop to this rogue production.
Do you think that the ozone hole will return to its 1980 size by 2050, as it was predicted, or this new discovery of this CFC 11 is going to delay that moment?
Well, that's a big unknown. I mean, as you say, we expected the chlorine loadings to get back to the 1980 values by 2050. So that sets this sort of timescale. The ozone hole was discovered in 1980, therefore it should sort of return to that size by 2050. So far, the amount of extra CFC 11 detected in the atmosphere is very small, and though the amount actually detected would not delay the ozone recovery at all to any measurable extent.
That's great.
Basically. But the big but is the fact that obviously the gas is being produced for a reason, and that's not to be emitted to the atmosphere. So what we've detected so far through the emissions is not all of the production. And normally a gas like CFC 11, you would use it to make, for example, foam, insulation foam. So there's a suspicion that maybe the gas has been used for insulation foam in buildings. Mm-hmm. And so the question is, how much of the gas made so far is still in the foam in buildings versus being released to the atmosphere, and the majority will still be in the foam in buildings. And the second question is, how long will this extra production go on? Will they put a stop to it straight away, now it's discovered, or will it carry on? So that introduces the possible delay. But we don't know, because we don't know what's going to happen to the production, but the overall results suggest the ozone layer will still recover, but maybe with a delay of about 10 years or so, as a rough ballpark. So it doesn't turn ozone recovery on its head, but it does sort of delay the recovery.
Since we're looking into the future, I mean, it's worth saying that studies have been performed to look at what would have happened in the future if the Montreal Protocol and its amendments had never been signed. So if we had continued to emit these compounds, these CFC compounds, into the atmosphere at a similar rate to as was occurring, prior to the Montreal Protocol coming into effect. And the results from those studies are absolutely clear that without the Montreal Protocol having come into effect to control these emissions, the destruction of the ozone layer would have become utterly catastrophic by the middle of the century. And not only would we have had this very large depletion over Antarctica, which we see today, but in fact globally there would have been very, very widespread destruction of the ozone layer, which would have caused very extreme biological damage to animals and humans and to plants at the surface. It would have completely altered the production of food. It would have changed skin cancer rates and other genetic anomalies globally. Another thing that's worth mentioning, I think, in relation to the link to climate change is that some of the gases that were used to replace these ozone depleting substances, of course, they didn't have the same effect chemically in the stratosphere on the ozone layer, but they were still greenhouse gases, and so they were contributing still to the surface temperature change on Earth. And this was recognised, and it had been talked about for some time. These are so-called hydrofluorocarbons, HFC gases, and the decision was taken by the parties of the protocol to put an amendment in place, the so-called Kigali Amendment, which actually set out plans to reduce the emissions of those HFC gases, to control those emissions under the protocol, with the main driver for that being to avoid further climate change. So in fact the sort of so-called world avoided by the Montreal Protocol, the contribution that's made to avoided climate change as an indirect consequence of controlling these greenhouse gas emissions has had a tremendous benefit to our efforts to try and slow down or to decrease the emissions of greenhouse gases. And it's been, so from that front as well, it's also been successful in terms of helping to reduce greenhouse gas emissions.
Is ozone depletion happening just in the Antarctic?
I know we're focusing on the Antarctic, which is the largest region of ozone depletion, but ozone depletion has happened in other parts of the world. Amanda mentioned the Arctic, but also at mid-latitudes there has been decreases in ozone, again through the sort of chlorine chemistry from CFCs and other gases, but to a much less extent. And we expect the ozone layer to recover in those regions as well, but unlike Antarctica, those regions are also affected by climate change. And so while we expect the ozone layer to recover, one of the biggest uncertainties in the overall recovery rate is how the atmosphere will change through climate change. And climate change for the stratosphere, where the ozone layer is, means a cooling. Obviously you think of climate change, global warming, but that just applies in the lower atmosphere. For the middle atmosphere, the stratosphere, it's a cooling, and a cooling can increase the amount of ozone. And so the rate at which ozone layer recovers in the middle atmosphere and outside of Antarctica depends on climate change as well.
And does the Arctic ozone hole affect surface climate conditions in the southern hemisphere as well?
In addition to its effects on sort of surface ultraviolet radiation intensity, the ozone hole has also had a pronounced effect on climate across the southern hemisphere, outside of the Antarctic region. So, and by climate I mean changes to precipitation patterns and to temperature patterns. So the storm tracks that exist in the middle latitudes on Earth, in the north and southern hemispheres, in the southern hemisphere, that storm track has been observed to have moved polewards over the last few decades, since the late 1960s or so.
Sorry, can you explain what is a storm track?
So the storm track, it's essentially a sort of belt of weather systems that track around the planet. So we have you might hear referred to in the news as a jet stream. That's a a band of westerly winds in the upper part of the troposphere, and weather systems develop on that jet stream and propagate along it. So we're very familiar, well, in the UK we're very, very familiar with this as being at the end of the North Atlantic storm track. We get all of these low pressure systems that develop and come into the UK and bring us our wet and windy weather. In the Southern Hemisphere there's the same thing. There's a jet stream and a storm track where weather systems propagate around the Southern Ocean, and that has moved polewards over the last few decades, and with that there's been changes to the pattern of precipitation across the Southern Hemisphere, and so that's impacted on a lot of people who are living in the Southern Hemisphere in countries in southern parts of Africa, in Australia, in South America. And it's been shown that movement of the storm track has been predominantly driven by the Antarctic ozone hole in the Southern Hemisphere summer season. So this is December, January, February. We think of it as winter in the Northern Hemisphere, but it's summertime, of course, in the opposite hemisphere. So in that summer season, those changes to climate have really been driven by the formation of the ozone hole. The increases to the greenhouse gases, carbon dioxide, methane and so on, has made some contribution, but really the dominant factor has been the ozone hole. And so as we move forwards into the future and we look at the expected recovery of the ozone hole, then there will be sort of opposite changes to the large scale climate of the Southern Hemisphere as a consequence as the ozone hole starts to heal and to close up. That effect will of course happen in combination with any further changes to greenhouse gas emissions. So depending on how future emissions of carbon dioxide and other greenhouse gases evolve over the future, the overall effect will be some combination of those two drivers, if you like. But it's an important fact that the broader influence that the ozone hole has had on the climate system, beyond what were previously well-known effects. For example, we've talked about, its effect as shielding the ultraviolet radiation from the surface, which is very important too. But actually it's interacted with other aspects of the climate system in quite pronounced ways.
Well, thank you very much, Amanda and Martin, for sharing your knowledge and insights with the Climate Press. It's been a great pleasure to have you on the show today. Thanks.
Thank you.
Thank you.
That's all for today's show. Thanks for listening. We hope you enjoyed.
Today's music was written and played by Cecilia Nicole from the Leeds College of Music and Marcos Arribas and Paloma Trascasa from the University of Leeds. On the next episode, we'll talk about ice sheets and climate change with Dr. Lauren Gregoire and Dr. Rusha Ivanovic from the School of Earth and Environment at the University of Leeds. Don't miss it!
Stay tuned for upcoming episodes and follow us on Twitter using @theclimatepress.
Please visit our website, theclimatepress.com. Our previous episodes are available on Spotify, Apple Podcasts, Breaker, SoundCloud, Google Podcasts, Pocket Casts, and Radio Public.
See you soon! And remember, make love, not CO2.